Good morning, Mrs. Rainy Connors. My name is Victor Moon, and today I'm going to be presenting technological applications of enzymes. What type, and our two main topics will be what types of food production processes use enzymes to improve their production yield and how they do so. So we are going to define enzymes, and enzymes are biological catalysts that speeds up the rate of chemical reactions. Enzymes work on substrates and convert those substrates to products. Examples of enzymes are amylase, ligase, cellulase, catalase, and many more. This is a basic this is a basic example of what an enzyme looks like and how they work. So this is an enzyme. As you can see, the enzyme is locking the substrate up. So you can basically call an enzyme a lock and the substrate the key. So the substrate, which is the key, fits into the lock, which is the enzymes, and the enzymes keys the substrate down and breaks it into two, forming a product. So there are many food processes that use enzymes to improve their production yield, and they are milk production, cheese production, baking, wine making, juice making. And in this research today, we'll be exploring how enzymes work in wine making and how they effectively increase the output of the wine that are being made. So we are going to be talking about pectin, which is basically the enzyme which is being used in winemaking. There are many other enzymes being used in winemaking, but for today we'll be using pectin. So pectin is basically the enzyme used in winemaking, though there are many other enzymes which could be used. Pectin is a type of soluble fiber commonly found in various foods. It functions as a thickening agent in cooking and baking, and it also has medical applications. Its primary role is to bind substances in the intestine, contributing to stool bulk. Additionally, pectin may have the potential to reduce the absorption of cholesterol from the food we consume. Although some people use pectin to address health concerns such as high cholesterol, prediabetes, heartburn, and diarrhea, it is important to note that there is not enough scientific evidence to support these uses. In the past, pectin was used often combined with kaolin, which is found in products like cowpectate, to manage diarrhea, which is basically stooling and vomiting at the same time. However, in 2003, the FDA determined that there wasn't sufficient evidence to support pectin's effectiveness for this purpose. Consequently, as of April 2007, pectin is no longer allowed as an ingredient in over-the-counter anti-diarrhea products like cowpectate. These products, like cowpectate, have since then been reformulated without pectin and kaolin. So, how does enzyme increase production yield in winemaking? So, enzyme increase. So basically, as I said before, we are going to be using vaccine and explaining how it increased production in winemaking. So there are three main steps in winemaking. There's extraction, clarification, and filtration. Fungi are used to start the grapefruit extraction process because they completely break down the pectins in the grapefruit to pectolytic enzymes. After the extraction is complete, it's then reacted with the pectolytic enzymes. The fruit juice extraction is the first step because it keeps the juice natural and adds texture to the wine. Now we go on to the second step, which is clarification. This process aims to remove impurities from the fruit juice extraction and transforms it into a clear liquid believed to enhance the flavor of the wine. Now then we move to filtration. This process helps release the red color in grape juice due to pectolytic enzymes. So I made a short note on how on pectin again. So now pectin is a structural polysaccharide found in cell walls of plants. It helps to hold the plant cells together. Plant cells with like grapes and stuff. So it helps to hold. Let's put it in the context. It helps to hold grapefruit cells together. Pectinase is an enzyme that breaks down pectin. The addition of pectinate to chopped fruit helps it to completely break down more cell walls so that more juice can be squeezed out. So that basically answers the question on how enzyme increase production yield in winemaking. Because when pectinase acts on the grapefruit, it breaks it down completely. It breaks down the cell wall so that more juice can be squeezed out. So advantages and disadvantages of using enzymes in winemaking. An advantage is enzymes helps to ensure and improve the quality of the wine. Another advantage is enzymes play a crucial role in enhancing the estimated yield of wine production. Enzymes improve the resource effectiveness of the wine. The disadvantage is enzymes are costly to produce, like very, very costly. It's not easy to get pectin or pectinase or get any enzyme anywhere. So if another substance contaminates the enzyme during the fruit extraction, it can alter the reaction. So now, as let's say in the extraction of grapefruit juice, if a substance contaminates the extraction in the grapefruit juice, it can completely alter the reaction, like completely disrupt the reaction. So enzymes are liable to any minor change in pH. Yeah, like any slight increase and slight decrease in the pH can alter the reaction of the enzyme. So basically, that's the end of the presentation. Thank you. A good day to you, Mrs. Renee Connors, and this is part two of what I'll be presenting. And my topic today is answers in cellular biology and related applications. And my topic that which I chose from the elements is new treatments for cancer. So basically, without knowing what cancer is, we can't possibly understand the new treatment. So cancer is a disease characterized by the uncontrolled division of cells that continue to multiply and spread to other cells, infecting them with cancerous cells. DNA changes often also responsible for causes of cancer, and in some cases, these changes can be inherited. So those are change. That means changes in DNA for cancer can be inherited. So according to Google, the first recorded cases of a cancer date back to the 1500 BC, during the reign of the Egyptian king. The image on the right of the slide or the slideshow shows a cancerous cell in the man's breast. Cancer is a major cause of death globally, responsible for 8.2 million deaths, which accounts for around 22% of all deaths which are not related to communicable disease. According to the most recent data from the World Health Organization, lung, stomach, liver, colon, and breast cancer are the leading causes of cancer related deaths each year. Unfortunately, the number of deaths caused by cancer is projected to continue rising, with an estimated 13.1 million deaths expected 2030, which is a 70% increase. So there are different and many type of cancers which we can't cover in one topic. They are too broad. They are too numerous. So today I will be explaining four main types of cancer, which are carcinomas, sarcomas, leukemias, and lymphomas. So let's start with carcinomas. This cancerous cell begin to attack the tissues that cover the surface of internal organs and glands, such as prostate, breast, and lung cancer. Those are examples of carcinomas. So sarcomas are cancerous is when cancerous cells develop in the tissue that support and connects body. So those kind of cancers can happen in fat, muscle, blood vessels, and joints. So leukemia is a type of cancer that affects the blood. The abnormal cells in the blood takes over the healthy cells and they continue to infect other healthy cells in the body. Because when the heart pumps blood, it pumps blood around the body. So once the leukemia is in the blood, it affects healthy cells, and those healthy cells continue to spread and affects and infects those other elder cells. So examples of leukemias include acute lymphocytic leukemia, chronic lymphocytic leukemia, and lympho. And our last type of cancer is lymphomas. This cancer affects the lymphatic system, injuring its abilities to fight infections. Example includes cutaneous B cell lymphomas and cutaneous T cell lymphomas. So we'll also be in this topic we'll also be comparing and contrasting old and new methods in treating cancer. Before the 1950s, surgery and radiation were the primary methods used to treat most cancers. Between 1949 and 1955, the only drugs available for cancer treatment were mecloretamine, which is the scientific name is NSC 762, ethylene estradiol, and many more. In early 1970s, advancements in ultrasound, computed tomography, which is CT scans, and magnetic resonance imaging and positron emission tomography, which is PET scans, allowed for the replacement of most exploratory surgeries. With the use of miniature video cameras and endoscopy, which is the stuff, yeah, colon, esophagus, and bladder tumors can be removed through tubes. Most recently, less invasive methods of destroying tumors without removal are being studied, including cryosurgery, which uses liquid nitrogen spray to freeze and kill cancer cells. Wow, that's going to be good. Laser can also be employed to cut tumor tissues in various organs, such as the cervix, larynx, liver, rectum, and skin. Currently, there are several effective methods of treating cancer, including hormone therapy, anti-allogenic therapy, stem cell therapy, immunotherapy, and dendritic cell-based immunotherapy. The new methods have effects on the individual immune system and they deaden the cancer cells that are in the body. So there are similarities and differences between old methods and new methods of treating cancer. Number one, they both use drugs to stop cancer from growing, which is basic here. Both old methods and new methods of treating cancer both use drugs to stop cancer from growing. So differences between old methods and new methods of treating cancer. New method kills fast-growing cancerous and non-cancerous cells. Old method boosts the immune system to identify and attack cancer cells. So now, an example of old method is immunotherapy, and an example of a new method is chemotherapy. So immunotherapy boosts the immune system to identify those cancer cells in the body and attack those cancer cells. While chemotherapy is straight up and fast, it just goes and it kills the fast growing cancerous cell and non-cancerous cell. So with that moves me to my second point. New methods work faster than old methods. Basically, what I've explained here in the first one. In while immunotherapy is still identifying and attacking the cancer cells in the body, chemotherapy goes straight and just kills the cancerous cell and both non-cancerous cell. So now, current effectiveness and future prospects in treating cancer. So, chemotherapy is considered to be one of the most effective methods for treating cancer. It targets cancer cells that cannot be removed through surgery or radiation. According to Dr. Dunbar, chemotherapy is also the only way to treat cancer that is not visible. The treatment has advanced to the point where it can specifically target the tumor, leaving healthy cells untouched. Philip D. Greenberg, a professor and head of immunology, believes that this is a time for optimism in cancer research. Greenberg expects that multiple areas of research will expand dramatically in the coming year. Sorry, in the coming year. Those areas include gene editing, epigenetics, structural biology for protein designs, and medicinal chemistry. Researchers are now able to target cancer cells proteins that were once considered undruggable. Greenberg also predicted an expansion in the use of a combination of agents that target independent cellular pathways and can work synergistically. The field of the field of engineered cell therapy is progressing rapidly. And that brings me to the end of my presentation. Thank you.